So next we're going to move on to solving more equations. I've called it solving equations part 2 or part 2, where we can apply algebra laws to simplify our equations before we actually go off and solve them. Those algebra laws like collecting like terms in rainbow or distributive property will take complicated equations and simplify them before we actually have to do the algebra rules to solve it. If we had to try and guess what a number was here for x, where you take 6 times that number and 4 times that number and have it equal 16 plus 4, it's a little harder to manage that all out right now. But we can go off and simplify using our rules and our laws to make the question easier. So example 5, I'm saying example 5 because I'm just continuing on from the other examples from solving equations, has a situation where we have 6x minus 4x. We know those are like terms, 6x minus 4x. So those can simplify into 2x. 6 apples minus 4 apples is 2 apples. 6x minus 4x is 2x. So that's the collecting like terms that we've already looked at in the first half of this unit, simplifying down to 2x. And of course, even 16 plus 4 can simplify to 20. So by using the collecting like terms, we've been able to take an equation that's more complicated and simplify it to make our life easier. Remember, I've said that mathematicians are lazy, but they're smart too. We've taken the rules that we know to make this question much, much easier to solve. And now it's just 2 times the number equals 20. We know the answer is probably 10, but we can also get it by dividing both sides by 2 to get that the answer is 10. In B, we've got, again, a complicated equation, but we can simplify it first and then solve. So the 9x and the 9x minus 7x plus x reduces to a 3x. 9x minus 7x is 2x. And then, of course, there's a 1 right there. So 2 plus 1 gets us 3x. And on the right-hand side, we have 15, which is pretty warm, but we're subtracting 18, which gets us colder, and it gets us into the negative 3. So using our like terms and simplifying, we've taken a complicated equation and simplified it into just 3x equals negative 3. Divide both sides by divide both sides by 3, and we get x equals negative 1 because a negative divided by a positive is a negative 1. Sometimes we need to put letters on one side, numbers on the other side. What does this mean? Well, it's hard to figure out what x is or isolate for x when x is on both sides of the equal sign. So a strategy you'll hear me say to solve for equations to put the letters on one side, numbers on the other side. It's a better way of saying isolating for x. So in order to isolate for x, we need the x's to be on the same side so that we can collect them. So in this case, instead of just moving a number, we're going to consider this 4x here and try and put it over onto the left side. Well, doing that, we're going to do the same opposite operation. So this is a plus 4x, so we're going to subtract 4x to take it from this side and remove it from this side. But of course, to keep everything in balance, we have to remove from this side as well. So with 6x minus 4x, collecting those like terms means that we have a 2x left over. So 6x minus 4x is 2x, and then of course the negative 4x has taken away this 4x, and all we're left with is 20. Now we've got our letters on one side, numbers on the other side, and we can perform the algebraic rules from before. Divide both sides by 2, and x equals 10. We can verify that this is the correct answer to this expression by substituting it into the left side. So if x is 10, 6x becomes 6 times 10, which is 16. And checking on the right side as well. 4 times x, or 4 times 10 is 40, plus 20 is 16. Because this works, it verifies that x equals 10 is the right answer. This part in red isn't something I'm going to expect you to do every single time, because that would take a lot of time for all the questions we're going to do. But if you're unsure of an answer, you can always check to see if your answer is right by doing this little operation, this verification. In B, again, we see numbers and letters all mixed about. So we'll want letters on one side, numbers on the other side. It doesn't matter which side we put the letters on, but most commonly, I'll put the the y's on one side. So in this case, I'm going to add the 5y here, and put the 5y on this side. So I'm trying to take this 5y and bring it over here by doing the opposite operation. 3y plus 5y gives me a total of 8y, and the negative 4 and the 12 remain where they are. This makes the question a little bit easier, but still, I've got numbers and letters here and only numbers here. I'd like the letters on one side, this number to be on the other side by doing the opposite operation. Adding 4 to both sides, then 12 plus 4 gets us 16, and we're left with 8y. Divide both sides by 8, we get our answer is y equals 2. So far we've been simplifying our equations by collecting like terms, but there are other operations that we learned in the first half of this unit to make even more complicated equations into easier and simpler ones. So if you have 2 times x minus 5, remember that when we're multiplying 2 times this monomial 2 by this binomial, we're going to rainbow. The 2 gets multiplied by the x and gets multiplied by the negative 5. So we'll do that operation first. 2 times x is 2x, and 2 times negative 5 is negative 10, equals 6. Remember that 2 doesn't get rainbowed to the 6 because it's not inside the brackets. So we've used the distributive law, or rainbow, to take this equation and make it look a little bit easier. Then letters on one side, numbers on one other side. We're going to leave the 2x here. Opposite operation to minus 10 is add 10 to both sides. It's going to leave us with a 2x, and of course 6 plus 10 is going to be 16. Dividing both sides by 2 gets us x equals 8. Sometimes we'll have in B, for an example in B, where we're going to have to rainbow a couple of times. So the 3 times the x times the 3. So 3 times x, and then times the 3. That's going to get us 3x plus 9. And on the other side, we're going to rainbow the 5. So the 5 gets rainbowed with the x, and the 5, and the 5 times x is 5x, and the 5 times 1 is 5. Then letters on one side, numbers on the other side. Again, there's nothing that says I can't move the 3 over here or the 5 over there. I generally just put the x's on the same side. So I'm going to subtract 5x from both sides. And 3 minus 5, so 3 is kind of warm, and I'm subtracting 5 gets me a little bit into the colders, so that's negative 2x. The 9 and the 5 stayed the same. Subtracting 9 from both sides. Again, 5 minus 9 gets us cold into negative 4. And then this time I don't just divide by 2 as I did in this question. I have to divide by the negative 2. And a negative 4 divided by a negative 2 gets me a positive 2. Regardless of whether I did things, I had to rainbow to make the question easier. To simplify first and then subtract, or then solve from there. You might have found it easier to move the 3x, so I could have subtracted 3x from both sides and got a positive 2x on this side and moved the 5 across. Just would have meant we'd have less negatives, but the answer would still end up being the same. And finally, we can get all of these combined into a question like this. So I see negative 4 is being rainbowed, and be careful when I rainbow this, I've got to rainbow the negative 4, not just 4. And so I'll rainbow that, and I'll get negative 4 times 2x is negative 8x, and then a negative times a positive gets me to negative 12. In this one, we got to be careful. This 10 is being subtracted, so we don't rainbow the 10. Rainbowing is a multiplying operation, but there is something that we do rainbow. We actually remember that there's a negative 1, a 1 right there. So the thing we are rainbowing is negative 1. Not the 10. The 10's just by itself. It's being subtracted to an answer, but of course BEDMAS tells me I have to do a multiplication before I can do anything with the 10. So I'm going to rainbow this negative 1. So a negative 1 times x is a negative 1x, and a negative times a positive 8 gets me to negative 8. Now we've got lots of letters and numbers on either side, so we want letters on one side, numbers on the other side. I think the easiest thing will be to add 1x to both sides. So the letters will all be over here. Negative 8 is pretty cold, but if I'm going to add 1, it gets me 1 warmer at negative 7. And the minus 12 stays the same. And then here I've got a 10 minus 8. So 10 minus 8 can simplify to a 2. You could leave the 10 minus 8 and do that subtraction later, but I just see that 10 minus 8 is 2, so I've simplified it and collected those. Still moving along, want letters on one side, numbers on the other side, so I'm going to leave this letter here, and I have a minus 12. Opposite operation is to add 12 to both sides, which gets me to 14, and it leaves me with a negative 7. And be careful to divide both sides by negative 7 to get an answer of negative 2. And if you wanted, you can go and take negative 2 and plug it into this equation and see that this answer is going to equal that answer. So going step by step and following this process will allow us to answer way more complicated questions than we could have even a couple of days ago, but should allow us to have some success. If you'd like more practice, there's a bunch of practice here. I don't expect you to do it all, but there's lots of practice for these questions that are going to be so important to everything we do in grade 9 this year.